So in light of similar triangles, let's do this example. Haley is estimating the height of the cyclone, shown here. This is the cyclone. Roller coaster in Galveston, Texas. She is 5 feet 3 inches tall, and her shadow is 3 feet long. She is 5 feet 3 inches tall, and as you can see in this picture, her height is, it says 5.25. So 5 feet 3 inches is equal to 5.25 feet. That's why it says 5.25. And her shadow is 3 feet. This is her shadow. If the length of the shadow of the roller coaster, this is the shadow of the roller coaster, if that shadow is 34 feet, how tall is the roller coaster? So what I'm looking for is this right here. What's the height? So I'm going to go ahead and put an X there to show that I'm looking for that. So if, when we're talking about the shadow of something, if you're standing right here and here's a shadow, this is technically a 90-degree angle right here. 90-degree angle. You form a 90-degree angle in comparison to your shadow. And so therefore we can say, as you can see here, this angle is a 90-degree angle right there. So that angle is the same for both triangles that are being formed. And let me just draw both triangles. So the triangle that we're talking about is this tiny triangle right here, in comparison to the big triangle, and I'm just going to highlight it in yellow. We're comparing that one, that black triangle, to the yellow one, or this pink one, whatever you want to think of it as. They both have 90-degree angles, and also they share this angle as well. This angle is the same as this angle at the top there, because it's the same. If you have the sun here, this is the sun. The sun is shining down in the same angle from the top of the roller coaster to end to the Haley standing. So it's the same angle for both. Now, because we have two angles that are the same, these two triangles are similar by the angle similarity. I'm going to write that here. So once again, by angle similarity, these two triangles are similar. This is the symbol for triangles. So because they're similar, we can write a proportion to find that missing side length. Let's write a proportion with the corresponding parts. So I can compare the two bottom parts, this bottom part of the triangle with this part. Those two are corresponding, they're matching, right? So I'm going to put the 3 at the top and compare it to the 34 in the bottom. This is a 34, can't really see it now. So 3 is comparable to 34. Now I'm going to then go in the same direction and compare the smaller one to the big one. So the smaller height would be 5.25, and let me pick a different color here, maybe purple. Say, okay, well now I'm comparing this height to the bigger height. So that larger height is what we're looking for, and so that's where I'm going to put an X. And now we just got to solve for X. We can do the butterfly method to solve. And so we're going to get 3 times X is equal to 34 times 5.25. And this is going to give me, if I put this into a calculator, I'll get 178.5. And I have 3X on the other side. If we're going to solve this by hand, we can go ahead and divide both sides by 3 to get our X alone, and our final answer is going to be X is equal to 5 9.5, and this is the height of the roller coaster. I hope that makes sense.